Okay. This is SOC Level 1, Core SOC Solutions, Elasticsearch, the basics. Introduction. In this room, you will learn how Elasticsearch ELK can be used for long analysis and investigations. Although ELK is not a traditional SIEM, many SOC teams use it like one because of its data searching and visualizing capabilities. We'll explore how the components of ELK and learn how log analysis can be performed through it. We'll also explore creating visualizations and dashboards in ELK. In this room, the following objectives: trying to understand the components of ELK and their use in SOC, explore the different features of ELK, learn to search and filter data in ELK, investigate VPN logs to identify anomalies, familiarize ourselves with creating visualizations and dashboards in ELK. Perfect. Okay, gotta restart my page. Yeah, we're back. Elasticsearch ELK was originally developed to store, search, and visualize large amounts of data. Organizations use it to monitor application performance, and perform searches on large data sets. Over time, its features made it popular in security operations as well. Now, many SOC teams use ELK almost as a SIEM solution. Elasticsearch is a collection of different open source components that work together to collect data from any source, store it, and search it, and visualize it in real time. Before we go on to learning log analysis through ELK, let's discuss its first components. So ELK, or ELBK, Elasticsearch, log stacks, beats, Kibana, I think, Kibana. Note, as an SOC analyst, your primary responsibility is to work with ELK to perform log analysis and investigations. You do not need to specialize in how each component behind the ELK works. However, taking a basic understanding of these components is essential. Elasticsearch. The first component. Elasticsearch is a full text search and am I saying that right? Analytics engine for JSON formatted documents. It stores, analyzes, and correlates data and supports a RESTful API for interacting with it. Please apologize for my reading. Logstash. Logstash is a data processing engine that takes data from different sources, filters it, and normalizes it, and then sends it to the destination, which could be Kibana or a listening port. A Logstash configuration file is divided into three parts, as shown below: the input part, the filter, the output. The input part is where the user defines the source from which the data is being ingested. Okay, where the user finds the source. Okay. The filter part is where the user specifies the filter option to normalize the log ingested above. The output part is where the user wants the filter data to be sent. It can be a listening port, Kibana interface, Elasticsearch database, or file. Logstash supports many input, output, and filter plugins. Beats. Beats are host-based agents known as data shippers that ship/transfer data from the endpoints to Elasticsearch. Each beat is a single-purpose agent that sends specific data to the Elasticsearch. All available beats are shown below. So we have file beat, lightweight shipper for logs and other data; metric beat, lightweight shipper for metric data; packet beat, lightweight shipper for network data; WinLog beat, lightweight shipper for Windows event logs, so that's for Windows; audit beat, lightweight shippers for audit data; heartbeat, lightweight shippers for uptime monitoring, function beat, serverless shipper for cloud data, the Beats family. They've been seeing a lot of Kibana. Kibana is a web database visualization tool that works with Elasticsearch to analyze, investigate, and visualize data streams in real time. It allows users to create multiple visualizations and dashboards for better visibility. There is more on Kibana in the following tasks. How they work. Now that we learned about all the components of the Elastic Stack, let's see how these components work together step by step. Beats collecting data. Okay, so we have Beats, Logstash, Elasticsearch, and Kibana. And they're all, okay, Beats. Beats collect data from multiple agents. For example, WinLog Beats collect Windows event logs, and PacketBeat collects network traffic flows. Logstash collects data from Beats ports or files, parses or normalizes into field value pairs, and stores them into Elasticsearch. Elasticsearch acts as a database used to search and analyze data. Kibana is responsible for displaying and visualizing the data stored in Elasticsearch. The data stored in Elasticsearch can easily be shaped into different visualization, time charts, infographics, etc. using Kibana. Logstash is used to visualize the data. So go back here. Logstash collects data for beat ports, files, normalizes into field pairs, and stores into Elasticsearch. So no. It stores it. Right? Yes. It lets you visualize it. It stores it. Kibana lets you visualize it. Elastic supports all data formats apart from JSON. So Elasticsearch. It's a full set for JSON formatted documents. It stores and analyzes it. See, it's right here. Full search and analytics engine for JSON formatted documents. JavaScript Object Notion is an open standard file data interchange format that uses human readable text to store and transmit data objects consisting of attribute value pairs and arrays. Wait, no, I confused myself. Engine for general documents. It stores, analyzes, and correlates data and supports a RESTful API for interacting with it. And it's asking us, supports all data formats apart. It literally says it literally only takes JSON. I have to read those questions, man. For proceeding with the following tasks, start the attached virtual machine by clicking the Start Machine below. Okay. This machine may take 3 to 5 minutes to start. After the machine starts, the ELK instance can be accessed at http. Yeah, I don't need to do that. You can see right there. We're just gonna put that inside the virtual machine. When it loads. Perfect. So this is from Splunk. So we're gonna just copy and paste. This thing is horrendously laggy. Damn, this is bad. Is that what I think it's about copy? So we're just waiting for this thing to take its sweet time. I might just actually just restart this or terminate it. Yeah. Let's try it all over again because it's super laggy. So wait while it takes a sweet time, probably cut all this one out. I don't really want to talk to this. So we'll cut all this one out. My heart feel like a beat. I'm gonna cut this all out from the video, by the way. Okay. All right. I'm breaking on. Here's another. I'm trying to turn my ways. 13. Like, I'm trying to turn my ways. Know about me. Say about me. Excuse me. All right. Now we're finally in. Finally. After that long awaited wait. So we're going to copy the IP address. Put it right into our lab. So it's giving us a username and a password for us to use to access. Analyst. The password that they gave to me is incorrect. Okay. That doesn't make any sense. Am I writing it wrong? What's going on? And this 1, 2, 3. Is there no capital? Like, I don't understand. It's showing the capital. The password has a capital. Doesn't show it. Okay. Let's reload the page. That's weird. And not caps. And list password capital and I'm really confused. Let's try one more time. I think I've got in now. Just a simple refresh. That took unnecessary time. Now we're finally in. Let's continue. Let's continue. From the task onward, we will discuss ELK's front-end interface. These are the main features that a SOC analyst operates on. As discussed in the second task of this room, Kibana is a component of the ELK that supports these interactions with front-end. Discovery tab. The Discover tab is where the SOC analysts spend most of their time. This tab shows the ingest logs, the search bar, normalized fields, and more. Analysts can search for the logs, investigate anomalies, and apply filters based on search terms and time periods. Interesting. Okay. Let's briefly see what each element as highlighted in the above screenshot of the Discovery Lab does. Okay. This is just like a dashboard. Logs, each row, so this is log right here. Each row shows a single log containing information about the event, along with the fields and values found in the log. This one is field planes. The left plane on the interface shows the list of fields parsed from the logs. We can click on any field to add it to the filter or remove it from the search. Index patterns. Each type of log is stored in a different index pattern. We can select the index pattern from which we need the logs. For example, for VPN logs, we would need to select the index pattern in which VPN logs are stored. It is a place where the user adds search queries and applies filters to narrow down the results. In the next task, we will learn how to perform searches through queries. Number 4. Okay, search bar. Time filters, time intervals, top bar, discovery tabs, add filters. So this graph right here. Excuse me. This graph right here is a time interval. When things, okay. Chart shows when the event occurs over time. Right. Narrow down results based on specific time duration. So, okay, that's nice. So you can really hone in on when you want to get your specific data. By default, Kibana requires an index pattern to access the data stored / ingested in Elasticsearch. The index pattern tells Kibana which Elasticsearch data we want to explore. Each index pattern corresponds to certain defined properties of the fields. A single index pattern can point to multiple indices. Indices. Am I saying that right? I don't know if I'm saying that right, but you get the point. Each log source has a different log structure. Therefore, when logs are ingested into Elasticsearch, they are first normalized into corresponding fields and values by creating a dedicated index pattern for the data source. In the attached lab, we will explore the index pattern VPN connections, which contains the VPN logs. Okay. Left pane of the Discovery tab shows the list of normalized fields it finds in the available logs. Click on any field and it'll show you top 5 values and the percentage of occurrences. Yada yada. We can also apply filters to any of these fields shown in the panel on the left. All we have to do is one click add the filter add the filter option under the search bar, which will allow us to apply a filter to the fields shown below. The time filter, so basically just a visualization of what I just said before. Select the index VPN connections and filter them from 31st December 2021 to 2nd of February 2022. How many hits are returned? Okay, so right, so now we're in Discovery. VPN connections. And he said let's do it as 2. Be easier way to just do it without going back and forth. Exactly. December 31st, 2021 to February 2nd, 2022. Code search. So ask how many hits are returned. So it would be 2,858. 2,858. Yep. Don't know how I repeated that. Just had to make sure. I'm confused. 258 hits. That missed a day. 2021, the 31st to February 2nd, 2022. I mean, nice how many hits. go back. I doubt it, yep. Only thing it's asking is for the hits, which would be obviously 2,851. So I don't know how that's wrong. Confused. I'm kind of stuck. The 31st of December, would the day, like, would the hour matter? Doubt it. February 2nd, 2025, 2022. Event time. Is not is. I wouldn't know. I don't see, like, I don't know about all of this. I thought it would just be asking about just general, like, how many hits happened in that day. I want to take a little deeper look before asking AI for assistance. These are the hits amount. So the time intervals, time duration. The left pane of the interface shows a list of fields parsed from the logs. You can click any field to add or field to remove to search. It's a place where the user adds search queries and applies filters to narrow down the results. Retrieve, combining, exploring, searching, analyzing raw data. This bar of various options to save the search. When save searches, share, save searches. That question is asking us. Traffic shows login based on time. Timeline pane provides an overview of the number of events that occurred. Let me try it again, but like I wouldn't. Okay, maybe the date. Okay, so it'd be 12 a.m. right? Am I right? Okay, from the beginning of the day to the ending of this day. Let's see. Everything has to be to the T though, so 286, 280. Let's see, that one is. Simple mistake just like that. Which IP address has the maximum number of connections? I think it's this 107.06397. Right? No. How would we find that out? Source country, source IP, correct. Less or equal to, greater than, is it greater than, exists in any form, both arguments must be true. Back to those days again, 'cause I'm pretty sure we're still using those same days. December 31st. Interesting. Okay. Not this one. So we're going to find out source IP. We focus on the IP. Right. If I'm doing this right, let me watch this video. So everything's just arranged perfectly. Okay. Asking what's the same maximum number of connections. I think about this 107.14. It wouldn't be able to be that. It has to be fill up the whole thing. Okay. Okay, so okay. The way I'm seeing it, focus on source IPs. But how would I know what's maximally used? I'm trying to figure out. Okay, I'm gonna use this. Did I do that right? Nope. Let's go back to field plane. The left plane on the interface shows the list of fields parsed from the logs. We can click on any field to add it to the filter or remove it from the search. See, with this thing being like half open, it's definitely right. Exactly. I couldn't see this stuff because of it being half. This would definitely be the highest. Even give us percentage wise. Which user is responsible for the overall maximum traffic? So we would go back here. We would definitely want to visualize. I think it's not even visualize actually. The access of which person, right? So they want us, which user is responsible for the overall maximum traffic. So since we found that out already, we go here. It should show us in filters too. But what's here? And here's our answer, swimming. Whoa. Which user is responsible for the overall maximum traffic? This is the maximum number of connections, overall maximum traffic. So this is different. Which user is responsible for the overall maximum traffic? Which user? So let's go to username. James. James, oh James. What are you doing? What are you looking for, James? It's not there. Apply filter on username Imanda. Which source IP has max hits? Okay. So go back to username. Now we're going to click on Amanda to add her to the filter. And that's asking us which source IP has max hits. Link to her, right? 107.14.48. Oh, 7.14.124. It's like a deep search on who, what, where, when. So the IP now is this one, 107.14.247. On the 11th of January, which IP caused the spike observed in the time chart? So we went to event, we were on the 11th, we went to event. Now we're going to go to source IP and see what was the highest. Bingo, there you are. 172.201.691, there you are. What are you doing, Alberta? Oh, it's Simon, sorry. Simon's pretty busy. Oh, Simon. How many connections were observed from IP 238.214, excluding the New York State? So what we're going to do to make this simpler, we're going to just copy. Very simple. Go back. Exit here. Exit here. We should go back to those dates just for safety. Okay, so they won't allow us. So let's stick to what we were before. Source IP. Or to paste exact IP. Yeah, I thought of this. I think because of the dates that we put. First, 2nd of January, 2nd of February. Let's not get mistaken. So in February, that's 2022, which is 2021. So Okay, so it's not coming up. Thought it would be easier like that. Oh, it's right here. 96 hits. $96. So you can do it just like that too. You just have to go back to it. Excluding New York State. Okay, yeah. Next word, time, event, time, port country, port state, exactly. Excluding New York. 48 hits. That's just Michigan. So all the regular schmegular. So all of this, the username, the country, IP address, port, time, everything is here. You just put it in, you'll definitely get a result for sure if you're doing it the right way. Remember the search bar. We saw the discovery tab in the previous task. We can find anything using this option. Let's see how. There's a special language that we can use inside the search bar to perform our searches. KQL, Kibana Query Language, is a search query language used to search and ingest logs/documents in Elasticsearch. Okay, with KQL, tongue twister, we can search the logs in two different ways: free text search, field-based search. Free text search allows us to search for logs based on text only. This means a simple search of this term security will return all the documents that contain this term, irrespective of the field. Let's search for the text United States in the search bar. It will return all the logs that contain this term, regardless of the place or the field. This search turned 2,304 hits. What if we only search the term United? Do you think you'll get any results? It didn't return any results because KQL looks for the whole term / word in the documents. So let's do it. United States, not tats. States. Okay, didn't show. Let's you cake. Okay, perfect. Kibana query language, and now it showed us 286. Now, United States. So there's none. Or do we alt it? On. So that nothing is any around. Maybe it's just searching around maybe parentheses would make it a little bit more better. Nope. Free text search allows logs based on text only. This means a simple search of the term security will return all the documents that contain this term, irrespective of the field. Let's search for the text United States in the search bar. It will return all the logs that contain this term, regardless of the place or the field. This search returned 2,304 hits as shown below. If you only search this term, United, do we get any results? No. KQL allows the wildcard apostrophe to match, that's not apostrophe, to match words, parts of the word. Let's find out how to use this wildcard in the search query. United. Let's try like that. Let's go back. United States. Just United States. So there's no United States for how many long? Logical operations are not KQL. Search query, United States and Virginia. 304 hits. Or operator. We'll use or operator to show logs that contain either United States or England. Operator is one of the options they give to us. Not operator. Similarly, we can use not operator to remove particular terms from the search results. This search query will show the logs from the United States, including all states, ignoring Florida. Perfect. Just like that last question they asked us. Is it including, added or including, not New York? So if I want to just look at Michigan, it would just show me Michigan if I put not New York. Perfect. Create a search query filter logs where search the source code, the source country is United States and shows logs from the user. You have to give me the timestamp. Okay. Which are the same timestamp. Okay, so I think I am supposed to be using the timestamp that they gave to me. January 1st to February. Let's try it. '22. I don't know about you, but I'm feeling 22. Everything's gonna be alright. February what? So just 1 month. I don't know about you. Look, it's showing United States here for the course. Why is it not showing it out for me? It's interesting. Okay. Source country, United States. But why can't I type it? So punctuation really does matter, ladies and gentlemen. If it's not spelled exactly the way, it won't show me nothing. And now it's asking me for the user James or Albert. So since we learned that we can go here, go to user, James, nope, not Anderson. Okay, let's use username again. Alberto Del Rio. My WWE fans will know that. So it's 101. Ooh. Oh, 9. What did we miss? So showing this James and Albert. Let's take away this username. He wants to use his name. We should just try it in a way that we're just saying just James. Usernames. It's giving me 101. Source country. ICs. Source IP. Sorry. Store username. Be Albert. And James. Albert's 53. This thing really does confuse me to a point. Why can I add both? Whether able to add the United States or England, and it shows. Why can I do that for James? We could do it all one together, right? Interesting. Source country. United. Username. James. Or username Albert. I'm trying to get this right. Plug in my charger. Definitely not Singapore. Say 2000. Let's go to user. James is showing 108. User. So how about your showing? Okay. So another one. Username is, this will be James. So we can't put both of them together, but 108 and 53. It should be able to allow me to do these both. James is 108, Albert is 53. It's 159. So it's not even that either. Okay, and let's try, okay, wait. Source country, United States, and username, James, and username, Al. So 108. That's just James. It's not showing Albert. It won't let me do two at the same time. That's weird. Or operator. We use the or operator to show logs that contain either United States or England. To create United States or England. Okay, I think I'm getting it. It can't show us in the, okay, so username. Okay, first let's put source country United States. Let's put username James or Username Albert. And when we go to username, it should show us. It's not showing both of them. Showing us right here, 101 records. United States, it's 101. How many hits is 101? Research query to filter the logs for source country in the United States and show logs from user James or Albert. How many records were returned? Records mean hits, right? Or am I missing it out? I got it. It's 101. Tell me it's not 101. Look at the United States. Shows logs from user James or Albert. How many records were returned? 101. Which is confusing. If I do it the other way around, so I just put it all together. Source. Gotta get this. United States. And username Albert or I was saying, okay. It's from 101, like. James 48, okay. Three and 48. I'm missing something. I don't understand. The answer should be 101. It's not making any sense to me. What am I missing? Create a search query to filter the logs where search country is United States and show logs from user James or Albert. How many records were returned? 101 hits. For both Albert and James. I just don't understand. I gotta make sure like it's not lagged out. Field view. doesn't make no sense. I swear to God. $53. Is it 340 equal to 108? 101? There's no way. There's no way that's even remotely possible. So I go here to user. James is 48. If I just click United States, go to user. James. I go to user, I go to James. James is showing 108. Oh my God. I go refresh. Say it's not James. Username is Albert 63. It doesn't make any sense to me at all. If I put them together, they should tell me the exact thing together. Why is it? This don't make no sense. Username exists. Username is one of James Albert. Make it make sense. Is don't give me two options. It's just one. Is not, is one of, is not one of, exist, does not exist. Or but they told us that or is an operator. And or not. Yeah. So James is just by himself, I guess. It doesn't make any sense at all. User Johnny Brown was terminated on the 1st of January 22. Such a search query to determine how many times a VPN connection was observed as termination. Johnny.